So, for the benefit of posterity and anybody who might not be in the room right now, we're having some IT issues with the projector, so I'm not quite sure. IT is supposed to be on their way, so. Wait, is this it? I have a dangling HDMI cable here. Is this it? We shall see. Try that. See here. Duplicate, I guess.
Are we doing a Unity lesson or visible or are we doing a Unity lesson?
No, no, this isn't going to be a Unity, like, I wanted to do, I think I was going to swap it and do like console this class and then Unity for the short class, because I've got more to show you in console than in Unity this time around. But I may have to do it on the board. So let's see here. If I can last ditch efforts to try to get the bloody projector working. Hi.
Here you go.
Yeah, thank you. That was fast. So I found when I arrived here, both of these were unplugged. So I've been trying various combinations to try to fix it. This is like a different setup than most of the others. Thank you very much. It's just here. That's that thing.
There's a switch here for USB because on the original TV is the usually the other TV.
Yeah.
But on this one, A is the computer.
Oh.
A is the I don't know which one's here. Sorry.
That would be useful.
Yeah.
All right.
When I go to B, that's right.
Right.
Hit like search. That will just
Okay.
right on there when I hit search. But I'll leave it on the projector.
Yeah. Thank you very much. I'm glad I caught you before you went home.
I'm working relations with people, so I'm sorry. But I'm hoping it'll work. Yeah, that's just usually going to sweep over.
Oh, we don't need some.
Sometimes they feel like most. Yeah, that's it. Yeah, leave it, I guess when you're done, close the door. The next one should work. Okay.
Sounds good. Thank you very much. Round of applause, everybody. Okay, so we do have.
You want this one? Sure.
Yeah. We might have more people come up. Maybe anybody expecting to arrive who hasn't arrived yet? Put your hands up, please. Nobody's coming. All right. That's a joke. This is a logical contradiction. All right, can we open up Visual Studio, please? project. C# console app. Create it, yes, good. Good, good, good. There we go. So, today, our object is to study objects. And that's a bit better. So, for the next few weeks in this class, we are going to be diving into object-oriented programming. Most of the programming that we've been doing so far would be called procedural programming. We are writing a procedure, right? Do this, if statement, do some other things, write a loop, the loop does stuff. That's the type of programming we've been doing so far. Object-oriented programming is a means for organizing procedural programming. In the same way that functions are a way of organizing procedural code, classes and objects are a way of organizing functions. Although in object-oriented we call them methods rather than calling them functions. So far so good? So, the idea with object-oriented is that we are fundamentally changing the way that we think about how code is structured. Previously, we were primarily concerned with, we have some input, we do some processing, we produce some output. The purpose of object-oriented programming is to simulate the concept of, concepts as they exist in larger reality. So, when we create an object, we want to talk about that object as we would an object in non-virtual reality, or as some of us programmers call it, meat space, because it's where things with meat, things made of meat walk around, like people. So, in actual physical reality, we have a concept of an object. It's a very general concept, right? So, for example, this marker is an object, right? This object serves certain purposes, and it has different states, right? In fact, this marker has, if we take a simplified view of this marker, it has one of two states, right? It is either uncapped or it is capped, right? You can also describe properties of this marker. It has a certain size, it has a certain geometry, it has a position in physical space, it has a weight, it has a temperature, roughly scientific properties, right? But it has other properties that are non-scientific as well, such as, what color is this one? You don't have to, that's a rhetorical question. The test questions get a little harder than that. So, we have markers in a variety of different colors, right? So you can imagine a marker object having a color attribute which could be one of a number of different colors, right? So that is how we think about objects in object-oriented programming. We define an object by talking about its properties and its actions. So uncapping a marker is an action. It doesn't do it itself, right? You have to do that to it. But you can imagine, you know, I have an uncapped method and then I have a capped method, which both set a Boolean variable is capped, right? What is another action that a marker might be able to take, assuming it's capped, it's been uncapped? Draw, write, etc. Yes, use it for its purpose. You know, draw. Yeah. Perhaps you could imagine a method where in goes a string, and then the marker writes the string. Right? Actions of objects are methods. Right? Is this making sense so far? So let's use a slightly different analogy. Let's talk about a cat. All right, let's imagine that we wanted to design an object, or design a class. Okay, let me back up for just a moment. We need to discuss the difference between a class and an object before we go any further. All right, so classes are analogous to categories of objects in physical reality, right? So a class is a category. That is to say, this is some particular marker. However, there is a category of objects, all having highly similar properties, that we would call marker, right? Like this is a marker, but we can talk about markers in general, right? We can talk about the category of markers. A class in object-oriented programming is a category describing possibly many objects. So the way that it works in programming is you write the class and then you create objects from that class. Another way of kind of thinking about it is that the class is somewhat like the DNA of the organism. The organism, like all of the organisms with the same DNA, are in some way essentially constructed from that DNA, right? So, you know, if you have two, if you have, in the case of like identical twins, two organisms that have the same DNA, they grow up to be different organisms, yet they grow up in the same manner to a large extent, you know, minus environmental factors, because they are working from the same blueprint, right? So another way of thinking of a class is as a blueprint, and the object is the thing constructed from the blueprint, right? So if I have a blueprint of a building, that's the class. If I have the building itself, that is the object, right? And because we're programmers, we want our blueprint to be useful for many buildings, as many as possible. Does this make sense? To some extent, hopefully. Any questions so far? Okay. So, just to try to cement the idea, let's discuss how we might go about writing a class to to describe a house cat. All right? So, let's imagine, this is a terrible marker. We'll use a different marker. Oh, it's an extra terrible marker. Nice. What sort of properties does a cat have? Fur, can you be more specific? What about fur?
Hair, flesh, hair, or
Like the presence or non-presence of fur? Or the color of the fur? Like, what are you talking about? Because like if it's, are we talking like hairless versus furry cat? Because that would be like a Boolean, right? Are we talking about length of hair? Because that might be a float. Are we talking about color of hair? That might be a string, right?
yeah,
So what do you think?
like the presence of hair.
Sure. So, Boolean has hair. Love it. How about another property?
Eye color?
Eye color? Sure. So I know we have like the color object in Unity, but let's just keep things simple. String eye color. So far we are not describing. So far we are not describing. We have not yet described a cat, which is not our fault because we've only got 2 properties up. We've basically described like all mammals have these properties, right? So what's something that what's something specific to cats?
Sound?
Sound? How do you mean?
That's the only thing that's specific to a cat, so it doesn't have, other does not have,
Like, do you mean the sound it makes?
yeah, whether it's more thick or more thin.
So here's a question. When a cat makes a sound, like, it gets a little bit tricky here, but making a sound is an action, right? So in theory, you could have a variable keeping like the type, like the quality of the sound or something like that. But in order to access the sound of the cat, we need to have a meow thing, right? Because meowing is an action that the cat takes. But yeah. So, yes? Sure. We're starting to get a little closer. Flows. Whisker length. Sure. Something else? What are some properties of cats that no other mammals have, or that are specific to the cat family?
So it's just their tongue. They have barred tongues.
Yes. So, string tongue is equal to barred. Now we're getting something. What's another thing that a cat has that few or not very many other animals have? Yes. Yeah, like night vision equals good.
Yeah.
Yeah. It's actually very interesting. Have you noticed that a cat's eyes glow at night? Do you know what actually causes that? It's fascinating. So if you have like a cross-sectional diagram of the cat's eyeball, you have like you have the part of the retina which contains all of the light sensing cells, right? For us, like, that's all we have, right? But for a cat, there's also a secondary, like, reflective layer behind it, so that a photon, like photons coming in, they might hit a photosensor in the retina on the first pass, but they have a second shot at it because they hit the reflective layer, and then they might again get hit, and they might again happen to hit a sensing cell in the retina, and then they come back out again. So yeah, it's kind of a cool adaptation because it effectively doubles the sensitivity of your eyes, because the photons have two chances to hit a sensor cell or sensing apparatus in the cell on the forward and the backward pass. But the secondary effect of that is, of course, light is reflected out of the eye, right? So, and if you'll notice, like, it's not like a perfect reflection, because like it always comes back as green, or like some kind of color like that. So like, it's not like this is like a silver oxide mirror or a silver mirror with glass or something, right? Like, evolution was not equipped to make a cat a perfectly reflective secondary surface on the underside of the retina, but does pretty good. It does pretty well. You know, the photons are affected by the process, but yeah, so that's why cats' eyes glow. Cool, right? It's not because they're demons. So, although if you were a medieval person, I would forgive you for thinking so. So enough said about the properties of cats. Now let's talk about some of the actions of cats. One which you said already, of course. Cats have the ability to meow. So we might have a public meow method. Right? Pardon me. What's another action that a cat can take? Yes? True. Fall damage equals 0. Yeah, so if I was just thinking about how like I would do that in code, but well, like I'm trying to think of it as a method. So like the part where you land on your feet would be inside of another method, which is like fall from height. Right? So you would have a method like fall, and inside that method you would have to ensure lands on feet, and then like you put that in the documentation for the method, right? Now, like the thing that gave me pause is like that weird twisting thing they do with their spine in order to land on their feet is an action, right? But I kind of want to keep it at a higher level of analysis. Like you could have this method call another method, which is like weird cat twist, you know? Ooh, here's another thing that makes cats somewhat unique. They have a very large number of vertebrae in their spines, which is kind of interesting. Like that's why they're so flexible, is because they have like a really large number of vertebrae. In comparison to us anyway, but you know, we're just a bunch of bipedal people, you know, why do we need all those vertebrae? So, what's another action that a cat can take? Or have I beaten this senseless? Yes? Sure. And that's something that is like highly unique to, like it has to do with the way that the cat's nose is constructed, that it can make that sound. Very good. Public? Purr. So, I think that's about correct. So that's the way that you should think about objects in an object-oriented sense, right? This is different from the way that we've been thinking about things so far. The way we've thought about things so far is when we write code, we want to take some input, produce some output or effect, right? But the output or effect has always been something external. Something external to the program that we're writing. Like, for example, draw a debug ray, right? We're not drawing the debug ray for the inherent good of the script in which that occurs, right? We are trying to get the debug ray to appear in Unity. That's an external effect, right? But when you start talking about classes, you're now talking about internal effects and external effects, right? So, for example, our class for cats might have a position, right? Position in space is a property of physically existing objects, right? It's a very, very time-tested truism that two objects cannot occupy the same space, right? So, if we have a method like walk, right? When I'm walking around, am I having an external effect or am I having an internal effect with respect to my position? External? Internal. So internal is actually correct. So my position in space is a property of me, the object that is me. When I call my own walk method, I'm not changing your position. I'm changing my position, right? So the effect is internal to myself. I am affecting my own properties, right? Does that make sense? So we're not always, yes?
I had a question about the external. Does
Yes.
that mean we have effect on others or others have effect on us?
So classes can have both, right? So in this context, we have an effect on others because we are the ones performing the action, right? So when you have an object and you have an action attached to the object, right? It is the object itself that is doing the thing, right? So with reference to the thing which is doing the thing, if I, for example, hand you a sandwich, right? From my perspective, you are external, right? If you hand me a sandwich, from your perspective, I am external, right? So in code, external is always with reference to things outside the class, right? So one of the things that classes do is they draw a boundary around code and properties and say, this is, all of this stuff belongs to the class, everything else doesn't, right? So when I say modifying an internal property, I mean this class has some properties, like these, you know? Perhaps if we were talking about chameleons, you could like have changes color, and it changes its own color. Like, it's a little bit, like that's a little bit facile because there's no reason to without some kind of environmental context, right? And that's the other thing to understand about objects in code. They don't fire themselves. Like they don't perform their own actions without somebody asking them to call that action, right? It's just like a function call. The function doesn't call itself. Something has to call the function. The same with methods of classes. The method doesn't call itself. It has to be called by something else. Make sense? Right? So the thing that calls it is normally another class, the method of another class. Now, certain classes, basically you get one per program. You can define a special class, or pardon me, a special method in one of your classes that does fire automatically, and that is called main. Main is the entry point into your program, right? We don't get to see it in Unity, but it's still there. Main is the thing from which all calls originate. In the C# console here, everything inside of these things we've been writing so far is implicitly in main, in a class. It's just hiding it from you to make it look a little nicer to deal with, in a way that Unity doesn't. Make sense? So far, so good? Are there any questions? Yes?
So, just to recap, classes are properties and methods of action.
No. Properties are properties. Methods are actions. Classes are collections of properties and methods. Does that make sense? Just like how a physical object could be thought of as a collection of properties and actions, right?
So that would be a class.
Yeah. So, like, I am a particular human, but you can imagine a general category of human where all humans share certain properties, right? And then, you know, you can get more specific from there. Preview for coming attractions in coming weeks. You might say, well, you know, it's all well and good to have a class for humans, but there are many different specific types of humans, you know. Perhaps take male and female, right? There are properties that males have that females don't have, and vice versa, you know. They have different organs even, you know. Not to bring sexual dimorphism into the lecture at all, but I just did. There you go. What you do is you define the human class such that it contains all properties common to both subcategories. And then you have those two subcategories, the word is inherit the properties of the superclass, right? So both male and female will inherit the properties of human, so that basically what that allows you to do is the male class contains only those attributes specific to males, and the female class contains only those attributes specific to females, right? And by doing that, basically you're minimizing the amount of work you have to do, because if the definition of human changes, right, and you need to update the code, as it were, you only have to do so in one place, because it's only in one place that all properties common to both of these groups are known. Does that make sense? We're going to be talking about that next week, though. So, shall we start writing some classes then? So, in our nice little C# console app project, let me share the screen. There we go. Oh. Yeah. The way that C# likes to think about classes is that each class should have its own file. So when you're looking at all, like, similar to having different scripts in Unity, when you create a new class in a C# project, it should be in a new file. This is not strictly enforced. You can have multiple classes per file, but as a general rule, one class per file. So, file, new, file, C# class, open. So you can see they have called it class 1. We may wish to call it something else. What should we make a class of? Anybody? Sorry? Doves? Like the birds? Dogs. Oh yes, because we did cats, let's do dogs. Okay, good. So public class dog. Don't worry about this bit in the middle right now. That's a constructor. We're going to get to those. Public class dog. Good. Now we will need to save this as dog.cs. The name of the file should match the name of the class. Good. So now we need to set some properties of the dog. So, it is normal for humans to name dogs. So let us give the dog a name property. Public string name. What's another thing that a dog may have? Don't worry about like making it too specific now. Just like, give me something. What's a property? Length of fur, sure. Public float fur length. Give me one more, please. Color of fur, sure. Public string fur color. Good. So, even only this far, we can do useful things with a class even this small. Alright? If you leave out all of the methods, what you essentially have is a way of packaging variables together. Alright? So, now that we have the class for dog defined, let us return to our program.cs, which is the thing that actually executes, and let's use it. Oh, by the way, this week is a quiz. So, this week is a quiz, yeah, quiz 2. Just a quiz. No lab this week. Just a quiz. Yes?
Who's on this? What are the quiz? The arrays or the object oriented?
Sorry, say again?
What's the quiz?
Oh, there will be some object-oriented stuff on it, but it's kind of also reviews like the array stuff and some of the loop stuff and stuff from the last 2 or 3 weeks of class, I'd say. So it's a bit more summative. It's not just on objects. Yeah. So, we have created a class. We should now create some objects from that class. we create objects the same way that we create variables from integers or floats or strings. We declare a new variable with the type being the class we wish to create, or the class we wish to instantiate. Instantiate. Right? So, dog A is equal to new dog. Sorry, give me 1 second. Fix this error. Miscellaneous files. What a bloody pain. All right. So, let's see. So basically, the problem is Visual Studio stupid. Sorry? So when it creates the class file, it doesn't actually automatically add it to the project. Yeah, which is dumb. So this is the procedure. All right. If you right-click on the tab and go to Open Containing Folder, you will get here your name, source, repos, dog.cs. I think console app1 is like the actual project folder. Yeah. So basically you just have to drop dog.cs, cut it, paste it in here. Right? C# files are communal creatures. They like to be snugly next to each other. Yes?
Can you say that one more time?
Say it a little louder.
Can you explain it one more time?
Yes. So this is the way that projects in Visual Studio think about files. There is the project source code folder. Any source code files for the project must be in this folder and nowhere else. So if you just create a new C# class file for some reason, it doesn't automatically put it in that folder. So you have to do it manually. Which means you go, it was originally here, you take it and you put it there. That will break this reference, so you gotta open it up again. Dog.cs, there we go, etc., save that, go to program.c, and you can see my error has been removed. Ta-da! Did everybody manage to get that done? Anybody need a hand? Let's see here. All right. So under repos, take dog.cs, cut, paste, paste, there we go, dog.cs, now there. Now this will be wrong. I'll say open dog.cs here, and there you have it. And the little asterisk means that it needs to be saved. Okay. So, does anybody else need a hand with that operation? We all good? So, we have created a new dog object named A. We may access the properties and methods of this newly created object using dot syntax. We have used dot syntax numerous times to access the properties of objects in Unity. If you recall, this dot transform dot position dot x, right? The dots mean I am accessing a property of the previous thing. So if I say a dot name is equal to, what's a good name for a dog? Really, nobody? Fido. There we go. A dot fur color is equal to tan. A dot fur length is equal to 3.4 float. There we go. We can both set and read the properties of an object using dot notation. This is not so very far off using something like dot enable in Unity. Right? Basically, Unity has a bunch of these objects pre-made with pre-made properties that you can access. Now we're learning how to make our own. Make sense? So far so good? Thumbs up? Okay. So, a very important thing to know about objects is once you have defined the class, you can create as many objects of that class as you want. You can even create an array of them. I create a dog array, doggos containing 10 dogs. Make sense? From there, I could say something like equals 0. I is less than doggos dot length. I plus plus. Doggos at I dot name is equal to Rover. Doggos at I dot fur length is equal to 1.2f plus I. There we go. So at the end of it, we get an array of dogs, all with the same name, Rover, with increasing fur lengths as you go through the array. Does this make sense? So far, so good? Okay. So, let me show you how to get information back out of these things. It's very similar to just reading a normal variable. Console.writeLine doggo. Let's put that in here. Doggos at I dot fur length. There we go. Now if we run the program, reference exception. Oh, yes, pardon me. So creating the array does not actually populate it with dog objects. You have to also say doggos at I are equal to a new dog first. Yes, yes, yes. There we go. So you can see we get so what we have recorded is 1.2, 2.2, 3.2, 4.2, etc. Make sense? So, shall we add a method? So, let us add a method that makes the dog bark. All right? For our purposes, barking shall be defined as writing a string to the console. Right? So, save. I'll wait for you to take your photo. Going back to our dog. What are you complaining about? Yeah. So it's basically complaining right now that I don't have a constructor, but we haven't talked about constructors yet. I should talk about methods in general before we talk about that specific one. So a method is an action. We define methods the exact same way as we have defined functions and methods so far. The difference is the location. So, public void bark. There we go. Console dot write line. Oof, oof. There we go. Or even name says woof woof. That way we get some kind of indication as to what dog we're actually, what dog is actually barking. make sense? So, does everybody have that down or something similar? Going back to program.cs, we can now say something like dog object, so a dot arc, or perhaps doggos at 3 dot arc. We run the app. Oh, forgot a space character. There we go. We see Fido says woof woof. Rover says woof woof. Does that make sense? So the whole point of methods is that they're doing something slightly different based on the properties of the class, right? So this is a somewhat, simple example because we are, this is, ultimately not really doing anything. But you can imagine, a method which sets the color of a three-dimensional object in Unity based on the stored color value inside the class, right? We have been working with classes so far. Each of the scripts in Unity which we have written is a class. It's only that they have a certain number of special methods, start, update, fixed update, etc., defined by Unity, which have particular behaviors in Unity. A class in C# console is basically a script inside Unity without those special methods. Does that make sense? Okay. Any questions? No? Are you guys finding this material digestible? Because the feeling I get, the kind of general feeling I get in the room is I'd really rather not be here right now. Is it the networking test? The networking test has you guys all down? Is that it? Yeah. Yes? Certainly. Try saving it. Save this one. Where is this? Ah. Yes, but did you? You've got 2 dog copies. This is dog. You wouldn't want dog. Yeah. That'll do it. You're very welcome. Is anybody else having difficulty with getting the code working? No, we're good. We're good. Cool. If I gave you guys a 5-minute break, would you come back somewhat refreshed and be able to be a little more enthusiastic about the class? Is that a possibility? Hopefully. Okay. Because I understand that you guys have the networking tests, but This is like really strongly fundamental stuff that is going to be really important for the rest of the course. So we will take a 5-minute break. Good. So, this example that we've done so far is a good example of a method having an external effect. Let's do an example now with a method having an internal effect. So, this is going to be a bit strange, but I'm going to do it anyway. Let's add a new property to our dog class. A public Boolean is married. Alright? Bool, sorry, not Boolean. There we go. So, let's say, we want to add a couple of methods which have an internal effect on this newly created variable, right? So, actually, I'm going to kick this one out to you guys. Write me a method that, assuming married is initially false, write me a method, get married, which modifies that variable and makes it true. And then when you're done that, write me a method called divorce that sets married to false. Okay? I'll give you a minute or two to do that. That's okay. Just copy down line 8 here, and then make the notes. Yes. Get married and divorced. Right? When you phrase it like that, married, it sounds like you're asking if he's married or not. Right? If you like put it in an active tense, it sounds like an action. been here for like a month. Hmm?
Someone.
Yeah, it's like, well, it was here for like 3 weeks, and now somebody has decided, oh look, I found this, if anybody has it, if it belongs to anybody, please take it. And it's like,
No one's gonna.
no one's coming back for it.
What is it?
Pop Daddy Pretzels Cinnamon Sugar Pretzel Sticks. It's very strange. It's just pretzels, but instead of salt, they've got cinnamon sugar on them. You know, they might have just left them behind because they weren't very good. I mean, of all of the ways that people find creative ways to like get people to eat carbohydrates, you know, like at a certain point, can't you just say carbs is carbs? I'm making a stand. There we go. Nobody's coming for it. And you know what? If somebody watching this video, that was your bag of pretzels, I will buy you a new bag of pretzels. Once you've verified your identity, I'm not buying pretzels for the whole internet. That just sounds like that would be expensive. You're getting regular ones though. Okay, so does anybody want a little more time to work on this, or can I show you guys how to do it? Good? We're good to see the solution? Yes? Okay. So, public void get married is married equals true. Public void divorce is married equals false. So, these are examples of what we call setters. A setter is a type of method which has some effect on the internal properties of the class or the object. We are setting is married. We can also go the further step of writing a getter. Public bool is married. Is this dog married? There we go. Return is married. This is the other common pattern. So, the purpose of this method is merely to get the value of is married out of the class, out of the object part, so that it can be used somewhere for some purpose that the class it's not even aware of, right? It's just like, oh, you need that information? Here you go. Right? Make sense? So let's imagine, just for the sake of interest, we want the dog to know which other dog the dog is married to. Seems logical, right? Would anybody in this room accept a marriage if you didn't know who you were getting married to? So, let's make a new property of, question, sorry?
No, I was gonna say,
Yeah?
we're gonna make a new one with the spouse name.
Well, not spouse name, but yes, we're on the right track. I'm going to make a new public dog spouse. Oh. So, and we'll set that initially to null. There we go. I will just leave it that way. So, would undefined work? No, that's JavaScript. Alright, so we're not just setting the name of the dog, right? We're getting a reference to another dog object, right? So, this works in a similar fashion to game object references from within Unity scripts. So now, when we get married, there is an important question we must ask. To whom? So, the marriage method must have a reference, it should have a reference to the dog that this dog is marrying, right? Because, you know, when you have a wedding, both parties need to be present. That's a legal requirement, right? So, dog, new spouse. Or, like, it's a little tricky because, like, I haven't, like, distinguished, like, male from female dogs, so I don't know whether to put, like husband or wife there, you know, and you're not a spouse until you're married. Fiancé! That's it! That's the word I'm looking for. Dog, fiancé. Accented letters are not supported in programming languages, so it's just fiance. Or perhaps betrothed. That's another one, good one. So, not only are we setting is married to true, we are copying a reference from the input of this method to our newly created spouse property. If there is anybody here with any reason why I should not assign this variable, speak now or forever hold your peace. So, does that make sense? And of course, what happens when we get divorced? You are no longer married to the spouse, so you can kill the reference, not the spouse. Important distinction. Spouse is equal to null. Does that make sense? So, when we get married, when two dogs get married, you have to call this marriage function on the one dog. But the other one just gets provided as an argument. Now, we're going to run into a funny situation, but I'd like to run this to show you how it works first. So let's just comment this with all of that out first. And let's just make two dogs, dog A and dog B. Dog A's name is Fido. Dog B's name, what's another name for a dog? Sorry, what?
Sparky.
Sparky, sure. Good name for a dog. That will have to be dog B. There we go. So now we can say console.writeLine a.spouse and a.is married, or alternatively we could also call is this dog married. Right? Then we can print the same for B. Let me just simplify this somewhat. Copy, paste, and in the middle, A dot get married to B. Make sense what I'm doing? I'm simply displaying the married and spouse properties of both dogs before and after calling the get married method. So let's see how it runs. So, a.spouse.name makes more sense. Okay, let me try again. Go. Yeah, okay. So spouse hasn't been set here, so those will fail on an error. Uh-oh, but this one's also failing on an error. So, does anybody know why we got through this guy, a.spouse.name, that worked, but b.spouse.name didn't work? Anybody have an idea? Chirp, 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 chirp. Crickets, crickets. Well, let's consider the dog.cs method. Get married. I'm setting the spouse of this object to the past dog reference. What am I doing to the spouse field of the past dog reference itself? This guy. Is this guy being modified in any way? It is not. So, basically, at the moment, we have implemented unidirectional marriage. So, I can be married to you, but you are not necessarily married to me, right? Which is, of course, not how marriage works, right? So, when the spouse of this dog becomes that dog, the spouse of that dog should become this dog. So, betrothed dot spouse will become equal to this. We've seen this in the Unity context a couple of times. What it means is a reference to the object that you are executing on, right? So this when this piece of code is executed by dog A, this is A. When this method is executed by dog B, this becomes a reference to dog B. Make sense? So this is just the self-referential identifier. Make sense? So, if we're going to set betrothed.spouse to this, we should also set betrothed.isMarried to true. There we go. Now, if we go back to program and run it, you can see that isMarried is false twice, then it's true for Sparky and true for Fido. So everything worked. But we're still not out of the woods yet, because at the moment we have effectively an implementation of dog polygamy. That is to say, there is nothing preventing a dog from getting married twice when already in the married state. Right? Fortunately, this is fairly easy to fix. Oh, hey, how's it going?
Good?
Am I too loud?
No, I just
Oh.
knew it was you, so.
Oh, yeah, okay.
Okay.
Yeah.
It's been a while. Seems to be designed to be my program.
Oh, neat. Yeah, we're talking about dog marriage. We currently have an implementation of dog polygamy that we're trying to fix. I'm teaching them classes.
Oh, yeah?
Yeah.
See you around.
Yep, see ya. So, basically, the fix for this is actually quite simple. The dog should not be able to get married if it is already married. Right? So, if not is married, do all of this stuff. Otherwise, say something like, console.writeLine attempt at marriage to married dog. Alert the spouse. Because presumably the spouse would want to know if, I know if my spouse, attended a wedding ceremony where my spouse was intended to be married to someone else, I would probably want to know that. Even if the procedure ultimately failed due to the state of already being married, it's still something the other spouse should probably know about. So there we go. This quite easily fixes it so that the dog cannot get remarried while still married. And of course, you should include all of this kind of stuff in the divorce method as well. But it's like mirror image, so I'm gonna just skip it in the interests of time. Feel free to fill that out as an exercise to the reader. So, there is one further problem with this, though. Currently, marriage can be hacked. So, both isMarried and spouse are public variables. This means that that anything outside this class has read and write access. So, there's essentially nothing preventing something in program.cs setting the marriage variable when the dog hasn't actually been married, right? So you could do something like this, right? Let's create a new dog. A new dog named Rex the Homewrecker. These are supposed to be funny. It's okay, you don't have to laugh. There we go. I would consider it a personal favor. So, if I marry A to B, and then I call A dot get married C, if I run that, come on, there we go. We get that error message. Attempt at marriage to married dog, alert the spouse. We flunk out that second one on an error message, right? But if I am the sort of programmer who's like, I just want to get it to work, I don't care how it works, so long as what I want happens, I'm happy. If that's the sort of person that you are, you could, in theory, just say A dot is married equals false. Because is married is a public variable. If you run that, the second marriage goes through and the spouse becomes Rex the homewrecker. Right? Yet, basically we're in an error state because 2 dogs are now married to Fido. Right? Obviously we want to try to prevent this. So, a thing that we can do, now that we have methods which control access to these variables, is we can make them private. Private bool is married and private dog spouse. What making a variable private does is it prevents access outside of the class, both read and write access. So it restricts it so that the little hack that we performed in program.cs on line 10, you can now see no longer works. That now produces a compiler error. Dog.isMarried is inaccessible due to its protection level, which is correct. What this program has put together, let no other programmer cast asunder. So, this does, however, have a secondary negative effect, or a secondary effect. Spouse is now no longer accessible either. So, we should, in this case, we can't access spouse.name because this is now private. So what we do is we write a method. We can write a method which allows us to read the value of the variable, but no method which allows us to set the value of the variable. So we go back to dog, and we write down public dog, returns a dog reference, get spouse, return spouse. There we go. Now, in our regular program, if we replace spouse with .get spouse with a method, we have full access privileges. This has the effect of locking down. We lock down write access. We don't have the ability to write to the spouse, but we can read from, because, you might need that for something. This forces any programmer using your class to use the marriage functionality in the way you intended it. Right? This forces them to go through your methods, which, again, forces them to, basically the reason you want to do this is to prevent any of a number of different error states, right? Regardless as to your sort of position on, marriage and what marriages should be, whether polygamy should be legal or whatever. Going with kind of the strict definition of marriage under Canadian law or whatever. We now have a marriage system which cannot be violated to produce error states like Fido being married to 17 other dogs. Right? Make sense? So there you go. From this app. So you can see that our output, whereas before we had Rex the home wrecker, it is now back to Sparky, which is correct. Yes. Make sense? I think in the last 3 minutes I can update the divorce method to include all of this. So obviously you should only be able to get divorced if you're married, right? So if is married, set not only my spouse and is married there, but also interesting. You can also say, before you delete the spouse, you can say spouse dot divorce as well. So that's calling the method from within the method, right? If I'm divorcing the spouse first divorces me. That is basically, well, that actually might result in that might result in a circular reference actually. Did I just write an infinite loop? No, I didn't. Interesting. Okay. So call spouse.divorce, right? For my own sanity, I'm going to set married equal to false here. So first we set married equal to false, then we divorce the other dog. That sets their marriage to false and divorces us. Calling divorce again if you're not married does nothing. So we exit that. Spouse is equal to null on both sides. And both dogs are divorced. Make sense? Cool. Well, I think that's about enough damage for one day. Hopefully you guys absorbed some of that.
Can you share the costs for us?
Yes, absolutely. Although, I must correct you, it is not codes, it is, I will share the program. Technically, the programs are written in a code, but there's one code between those two classes, and those classes constitute one program. The code is C#. I get to be pedantic about that sort of thing because I have a PhD.